turns around, up, down, because it's AC. And now I have here a conducting plate. And I put this above this plate. But now I have this continuous magnetic field change. So I have a continuous change of magnetic flux in that plate. So as this magnetic flux, as the B field down is increasing, you're going to get an eddy current running in this direction, which will create a magnetic field in that direction. And you're back where you were. You again have North Pole, South Pole, South Pole. So again, the eddy current in the conducting plate is responsible for a magnetic field, and the two repel each other. So a little later in time, the magnetic field strength will decrease. When that happens, the eddy current will reverse direction, and the two will attract each other. And so you will think now, it seems quite reasonable, that half the time they will attract each other, and the other half the time they will repel each other. That, however, is not the case. There will be a net repelling force. And why that is, I will explain to you during the next lecture. But I want to demonstrate it now. I have here such a coil, about an area of about 1 square foot. I can simply run 110 volts, 60 hertz AC. If I switch this or turn this on, just goes into 110 volt outlet, and I increase the current, starts to float. No high-speed train, nothing superconducting. What do you think will happen when I turn it over? Excuse me? Of course it will float again. The eddy currents just adjust themselves at any moment in time, and they will always make it float. So this is another interesting form of magnetic levitation. So we have the superconducting way, whereby there is no dissipation in the disk. So those currents never die out. Then we try to get this magnetic field, and believe me, Marcos and I and Bill, we really tried. But there was a problem, because we needed enormously high currents to get this magnetic field. And at these very high currents, our circuit breakers would go every time. So we called up the physical plant, and they said, yeah, what do you expect, man? You need several hundred amperes. You think we can get several hundred amperes out of this system? You have to redesign MIT for that. So it was very disappointing for us. So the best we could do with the strongest current that we could generate, we could only get a magnetic field of about 350 Gauss, which is 4 times lower. And the tragedy has it that the magnetic pressure goes with B squared. So that makes it 16 times lower. So the 200-pounder now becomes a 12-pounder. So that's the reason why, when some women wrote me very nice email yesterday, because they volunteered, why I had to say thanks, but no thanks. But I want to keep my promise. I said I was going to levitate a woman, and I will. And here she is. And as far as we know, it is a woman. Okay. Give her some room. She deserves. We ready for that? And there she goes. I levitated a woman. Have a great spring break.